Now we'll try to apply the tangent to some specific right triangles. On our right, the tangents of the acute angles of the right triangles, says you want to write each answer as a fraction and as a decimal rounded to 4 decimal places. So I actually want to do both. Number one, here's what we can find the tangent of. Again, it's a tangent of the acute angles. Kind of doesn't matter the order, either R or S. I'm going to do R first because it comes before S. If you did S first, that's fine. But again, here's what you have to remember. The tangent of an angle is, I'm going to abbreviate this, just opposite over adjacent. Because once we go over each of the 3 trig functions, there's a little trick, tip, kind of phrase that you could use in order to remember each of the 3 trig functions. But for angle R, the side opposite angle R, that's basically right across, is 45. The side adjacent, again, that's the leg adjacent or the non-hypotenuse, is 24. And then you could simplify that. It says, write each answer as a fraction. Really what that should mean is a simplified fraction. So to simplify that, you could divide both 45 and 24 by 3 to get 15/8. So that's the simplified fraction, but always make sure you follow directions. And then as a decimal, rounded to 4 decimal places. So then I could just take 15 divided by 8, do that on your calculator in all likelihood, and then make sure you're rounding that to 4 decimal places, 1.875. We could also find the tangent of the other acute angle, angle S. It's still the side opposite over the side adjacent. Now what's opposite angle S is 24. What's adjacent to angle S is 45. So that should simplify to 8/15. And then if I round it to 4 decimal places, 8 divided by 15, rounded to 4 decimal places, it's approximately 0.5333. That would be to 4 decimal places. Okay, but that's finding the tangent of each of those angles. All right. Next, I want to go over some examples where we're given an angle. It says find the value of x, round your answer to the nearest tenth. So here's the only thing that we've gone over so far is tangent. So you really should be using the tangent in order to find the value of x in this case. 10 degrees, that's an acute angle of the right triangle. That's what you take the tangent of. So the tangent of 10 degrees is equal to the side opposite 10 degrees is 5. The side adjacent to 10 degrees, that's not the hypotenuse, is x. So I could solve this for x. Okay, the variable's in the denominator, so it's a little bit more complex. If I want to get x out of the denominator, I'd actually need to multiply each side by x. Then we get x times the tangent of 10 degrees is equal to 5. And then in order to solve this for x, we have to divide each side by the tangent of 10 degrees. Now the rest you're going to need your calculator for. Okay. On your calculator, here's what you want to make sure of. Basically every single time. On your calculator, it should be a scientific calculator, first of all. If you're looking one up online, make sure it's scientific. Okay. The next is you have to make sure that you're in degree mode. I think on a lot of the graphing calculators, the default is that you're in what's called radian mode. You'll learn about radians next year. So you want to change the mode to degree mode. I just needed to change that on my graphing calculator. Okay, let me just show you real quick. So on my calculator, initially under mode right here, if I looked on the 3rd line down, sorry, it's actually the 4th line down, it says radian degrees. It was just highlighted radians, so I had to scroll over, highlight degrees, enter, and then I could just clear that out. Now my calculator is in degree mode. And I think what happens every single time as well, if I turn off my calculator, when I turn it back on, I think it'll be reset to radian mode. So you always have to double check, because in geometry, when we're talking about angles, we're talking about angles in terms of degrees. But I still need to evaluate and solve this for x. So sorry I didn't write it. X is 5 divided by the tangent of 10 degrees. And that's what I entered in on my calculator. 5 divided by the tangent of 10 degrees. I know you can't see my calculator, but I just entered that in my calculator. It says round your answer to the nearest tenth. So on my calculator, I get 28.35. So x is about 28.4. Okay. That's if the variable is in the denominator, a little bit more complex than if the variable was in the numerator. There is a way that I can set this up with the variable in the numerator, and here's how. If you know that this angle is 10 degrees, you can find the complement of that. This is 80 degrees right here. Then what you could set up is the tangent of 80 degrees. That's still an acute angle of the right triangle. But now the side opposite 80 degrees is x. The side adjacent, that's not the hypotenuse, is 5. If you want to solve this for x, you would actually multiply each side by 5. And here's what we get. X is 5 times a tangent of 80 degrees. Try that on your calculator and then see what you get for your answer. If you try that on your calculator, you should get the exact same thing here. I think for a lot of people, though, it's easier with the variable in the numerator. There's probably going to be some problems that we'll go over where it's unavoidable that you have the variable in the denominator. Okay. But let's go over number 5. So this is actually for number 4, all of this. But number 5, we want to find the value of x. Here's the acute angle. That's 64 degrees. So we can start building our trigonometric equation. The tangent of the acute angle, 64 degrees, is the side opposite that. What's opposite 64 degrees is x over the side adjacent or the leg adjacent. That's 13. If we solve this for x, we multiply each side by 13. Then x equals 13 times the tangent of 64 degrees. Sorry, I didn't mention this earlier. You probably figured it out. For basically all the problems, we're going to need a calculator. So you enter this on your calculator, 13 times the tangent of 64 degrees, about 26.66. I took that back. I went around to the nearest 10, not 100. So about 26.7. And sorry, that was number 5, not number 6.